Section 1. Introduction to OS Debugging. Operating system or OS debugging is a crucial aspect of systems programming. It involves identifying and resolving errors or bugs within an operating system's code. Debugging is essential for ensuring the stability, reliability, and security of the entire system. Understanding how to effectively debug an OS is a fundamental skill for any aspiring computer scientist. OS debugging differs significantly from application debugging. Unlike applications that run on top of an OS, the OS itself forms the foundation of the software stack. Consequently, OS debugging often requires specialized tools and techniques to access low-level system components and analyze their behavior. The complexity of operating systems makes debugging a challenging task. Bugs can arise from various sources, including concurrency issues, memory management errors, and incorrect device driver interactions. Effective OS debugging involves a systematic approach, combining code analysis, log inspection, and the use of specialized debugging tools. By mastering OS debugging techniques, computer science students gain a deeper understanding of operating system internals. This knowledge is invaluable for designing, implementing, and maintaining robust and reliable software systems. Section 2. Essential debugging tools and techniques. Debugging tools help identify and resolve OS bugs. They provide insights into the OS, allowing developers to trace execution and analyze events. Debuggers control OS kernel execution with features like breakpoints and single-stepping. Logging records system events and error messages. Analyzing logs helps identify the root cause of bugs. Memory analyzers and performance monitors detect issues and optimize performance. Section 3. Navigating common OS debugging scenarios. OS debugging involves resolving common scenarios. A common scenario is a system crash, displaying an error message. Debugging crashes involves analyzing crash dumps. Concurrency issues like race conditions and deadlocks are frequent. Specialized tools track thread execution and detect race conditions. Memory corruption occurs when a program writes to an incorrect memory location. Debugging memory corruption requires code inspection and memory debugging tools. Effective OS debugging goes beyond simply using tools. It involves developing a systematic troubleshooting approach. This approach typically begins with gathering information about the problem, including error messages, system logs, and user reports. Once sufficient information is gathered, the next step is to formulate a hypothesis about the cause of the bug. This hypothesis should be based on the available evidence and a thorough understanding of the system's behavior. The hypothesis then guides the debugging process, directing the developer's attention to specific areas of the code or system configuration. Testing the hypothesis often involves using the debugging tools and techniques discussed earlier. This may involve setting breakpoints, inspecting memory, or analyzing system logs. The goal is to gather evidence that either supports or refutes the initial hypothesis. If the initial hypothesis proves incorrect, the debugging process becomes iterative. The developer refines the hypothesis based on the newly gathered evidence and repeats the testing process. This cycle continues until the root cause of the bug is identified and a solution is found. Several practical tips can greatly enhance the efficiency and effectiveness of OS debugging. First and foremost is the importance of writing clean, well-documented code. Clear code with meaningful variable and function names is easier to understand and debug. Another valuable tip is to use a modular design approach. Breaking down complex systems into smaller, more manageable modules simplifies debugging. By isolating functionality within modules, it becomes easier to identify the source of errors. Testing is an integral part of the development process and should be incorporated from the earliest stages. Regular testing, including unit tests, integration tests, and system tests, helps identify bugs early on, making them easier and less costly to fix. When encountering a bug, it's essential to remain patient and persistent. Debugging can be a challenging and time-consuming process, but a systematic approach, combined with the right tools and techniques, will ultimately lead to a solution. Mastering OS debugging is an essential skill for any computer science student aspiring to work with operating systems or other complex software systems. While it can be a challenging endeavor, the journey of debugging provides invaluable insights into the inner workings of operating systems. By embracing the debugging process, computer science students develop critical thinking skills. problem-solving abilities, and a deeper understanding of operating system concepts. The ability to effectively identify, analyze, and resolve bugs is a highly sought-after skill in the software industry, making OS debugging a worthwhile investment for any aspiring computer scientist.